Our first section is the areas of triangles and parallelograms. Now, most of this you have seen before, but hopefully we'll make it a bit harder. So most of this you've already seen. You already know the formula probably for triangles, and we're going to make it a bit harder. But like I said, this first section should be pretty straightforward. So 11.1, areas of triangles and parallelograms. So we're done with circles for the time being. So the first thing we need to do is talk about what are the formulas. Now, like I said, I will give you a formula sheet. You guys should probably already know these, but we'll go through them anyway. The formula for the area of a square. It's length times width, but actually for a square, the length is equal to the width, right? Because all the sides are equal. So the formula for the square is s squared. All right, kind of nice, right? S squared. And the picture, very simple. You have a square. For the angles are the same, for the sides are the same, and each side is length s. So yes, length times width would absolutely work. This is just a special case where all the lengths and the widths are all the same. Okay? So a capital A always stands for area. When it gets more confusing, what I'll start doing is adding in the shape. So if I did the area of a square, I'm going to do area and then a little square underneath. So that tells me it's the area of the square. The area of the rectangle is equal to, Anthony? Length times width. Traditionally, the length is your longer side and the width is your shorter side. So your picture your length is the longer side, your width is the shorter side. You guys have seen these all before, right? You may not have seen a parallelogram yet. The area of a parallelogram, am I going too fast? The area of the parallelogram is very similar to the area of the rectangle, and I'll show you why in a second. But it's called two different things. It's called the base and the height. Base. Come on. The base times the height. Okay? And this one might be a bit confusing. So a parallelogram looks like this. The base and the height can be either side, so they can switch. So I'll do it. I'll label one with the blue and one with the red. Okay. So for the first one, the base is my bottom piece, and the height is the perpendicular distance to the other base. So if this is my first base, my other base would be at the top. And the height is the perpendicular distance between them. That means that you have to draw a line called the height, and the height is perpendicular to both of those sides. Does that make sense? Okay? It's the perpendicular distance between the two bases. All right? It's very similar to a triangle. We'll talk about it in a second. The other way you could do it, let me draw another one. If we drew another one, it could be the same shape. If my base instead is the other edge, doesn't matter which one you label it, which side. So if my bases are the other sides in this case, the height has to be perpendicular to them. So for example, notice how I extend this line out. It's still perpendicular to it. And it's also perpendicular to my other base. This would be my height, h. That one is a lot harder to see, right? That one's a lot harder to see. The first one's usually easiest. The easier way to do this is usually to choose your longer side as the base and then find your height. Okay? We're going to do some practice problems. This one is kind of weird. You still have your bases, and you have to find a horizontal distance between them. If they're not perpendicular, you have to extend the side, which is why I drew this dotted line in here. Hang on one second. Anthony had a question first. The base here actually doesn't matter. I understand you because you like it to be the top and the bottom. The bases here don't matter for the formula as long as you change the height with it. So if you chose the bases of the two other sides, you have to choose the height in the other direction as well. So if you want to view this as rotated, you can do that. Alicia? Let's get to some practice problems and then we'll work on it, okay? The triangle, the area of the triangle, what is the formula? Yeah, half the base times the height. And maybe this will help. There are two possible ways we can draw triangles. We can draw triangles that are acute or right. Oh, let me draw all three. We can draw acute, we can draw right, we can draw obtuse. Everybody see all three types of triangles? Alright. The base, we can pick any side. You can pick any side to be the base, just like the parallelogram. It's usually easiest if you choose the bottom. So my base for all these will be the bottom. Alright. Now the height has to be perpendicular to the base. So if my base is the bottom, the height has to go straight up and down. For my first triangle, notice that my height is going to be inside of the triangle. Everybody see that? For my right triangle, however, my height is actually going to be right on top of that line. So my height is actually going to be the second side. Does everybody see the difference between whether it's acute or right? And for the last one, notice how we need to go to the third point? How we need to go straight down? So for my last one, I go straight down, but then I need to connect it with this line coming out from the base, because they have to be a right angle, and my height is this distance off to the side. Okay? So the height does not have to be an actual line. Okay? It can be an imaginary line. Notice how the height isn't actually part of the triangle in the first or the third picture. On the second one, it is one of the sides, because it's a right triangle. Right? Where do these formulas come from? Well, you don't need to write this down, but I wanted to compare the area of a parallelogram versus the area of a rectangle. The parallelogram looks like this. Right? If I chop off this edge of the triangle, everybody see this? If I chop it off and I move it to this side, do you see that it would add on right there? Everybody see that? So the parallelogram, the area for the parallelogram and the area for the rectangle are almost exactly the same. The only difference is that instead of length and width, we call it base and height. Do you see how if we cut this piece off and moved it over there, we'd have the rectangle? Do you see the base and the height? You see how it kind of forms a rectangle right there? So the parallelogram and the rectangle are very related. Come on. Sorry. The area of the triangle versus the area of the parallelogram. Well, this time let's start with the parallelogram. Doesn't matter what shape. You remember the parallelogram was base times height, right? What's the area of a triangle? Half the base times the height. If I cut any parallelogram in half, what do I get? A triangle. So you should see that the area of a triangle comes from the parallelogram. Another example, even though this looks like a rectangle, is that still a parallelogram? Yes. Cut it in half, you still have a triangle, except now it's a right triangle. Okay? So do you see how the area of the parallelogram is related to the area of the triangle? It's just cut in half. Okay. Any questions before we get into the numbers? What I will do is I will give you a formula sheet that will have some of these on it. It will also have some of the surface area, the volume and surface area stuff that we'll get to in a second. All right. So that will be, hold on to it until the end of the year. I'll give it to you on Wednesday. All right, so find the area and the perimeter. Find the area and the perimeter, right? So I'm going to focus on units a lot. If they're not given, I want you guys to write down unit. So for example, this does not say 8 inches, so it's saying assume 8 units. Okay? Which would you like to do first, the area or the perimeter? Area? I heard most. So what shape is this? Triangle. What's the formula for a triangle? 1/2 the base times the height. All you need to do is plug and chug. What is my base here? 21. What's my height? 8. Good. Could my base have been 10 if they gave me a height like this? Yeah. Your base is always going to be perpendicular to your height. Brian? You don't. However, it will help keep you organized. Especially when we get to more complicated shapes, it might be helpful. It's up to you. So the area of the triangle is 1/2 the base, which is 8 units, times the height. Oh, I'm sorry. Mix those up. Which is 1/2 the base, which is 21 units, times the height, which is 8 units. All right, a little trick. How many of you want to multiply 21 times 8 first? A trick, because that's fine. Do the 1/2 times the 8 first. All right. So if you do the 1/2 times the 8, what is 1/2 of 8? 4. Then do the 4 times 21. 84. All right. You don't have to do it that way. You can do the 21 times 8 and then divide by 2. It doesn't matter. But at the end of the day, you need to multiply all 3 of them. It doesn't matter which order, though, you go in. So sometimes it's easier to do the 1/2 so you get smaller numbers to work with right off the bat. All right? All right. So we could do this 2 ways. We could do 1/2 times 21 times 8. Well, 21 times 8, can I do that in my head very well? Yeah. I think you guys overestimated me. 168. Then you have to do 1/2 of 168. 84. Okay? That's great. But I think that takes more effort than doing it the way I did, which was I did 1/2 times 8 first. What's 1/2 times 8? 4. So I get the 21 stayed the same times 4. Those are much more manageable numbers. They're smaller. Does that make sense? Yeah. Then you just do 21 times 4 and you get 84. It doesn't matter which order you do them. I just like to work with smaller numbers so I can do it in my head. All right? Gloria? Why don't you do 1/2 times 21? Because then you're going to get a decimal. You could. It's just going to get, I think that's the worst way. It's going to be the most effort. Oh, try to always do the small number. Try to do it the small number first if it's divisible by 2. Don't fret, though. You can just multiply straight across them. Right. So what would my units be for the area? 84 what? Units. Whenever you have an area, you have to have square units. So square inches, square centimeters, square feet, square mile. Yes.
Do we simplify units with square?
No. The perimeter, do I need to do it here? It's just 17 plus 10 plus 21, dot, dot, dot. We've done that enough, right? Okay. The second shape. Is the 8 the perimeter? So leave it out. Perimeter only is around the shape, correct? So walking around the shape. The 8 is not a part of that. What is the second shape? Okay. So the area of the parallelogram, I'll do this in a different color. What is it? Base times height. I'm going to do this problem two ways, okay? Just like I said, it didn't matter before. There's one way it's going to be pretty obvious to you guys, and one way it might not be. Anybody want to take a stab at this for the base and height? Ernest? The base is 12, so Ernest says the area is equal to the base, which is 12 units. If 12 is the base, Ernest, what is the height? 4. Does everyone see how the base is perpendicular to the height? Everybody see how the base is perpendicular to the height? So it's 12 units times 4 units. The base is perpendicular to the height. Okay? It's not 6 because Ernest chose to use 12 as his base. All right? The base always must be perpendicular to the height. Notice that 12 and 6 are not perpendicular. Patricia?
If Q and T, the line of Q and T keeps going, will they hit in U?
Not necessarily. It looks like it doesn't here, but it just depends on your shape. That's just a coincidence.
Shouldn't the height keep going through the whole shape?
We're only looking at the shaded region here.
Oh.
I'm sorry, I thought it was confusing. This is like a dashed line on the outside. We're only looking at the shaded region. Okay? So my area of my, the area of my parallelogram, 12 times 4? 48 units squared. If I wanted to find the perimeter, if PS is 6, what is QR? 6. Because parallelograms have the same side lengths on opposite sides. So this would be 6. What would RS be? What would RS be? 12. Because it's across from QP. So my perimeter would be 12 plus 6 plus 12 plus 6 equals 36. Okay. Now, I want to show you the other way we can do the perimeter, or the area. I said there were two ways. Ernest chose the 12 to be his base. What's the other thing I could have chosen? Do you know? It could be the 6. So let me erase this. And let me show you what it would be like if we did 6. So if I chose, I'm going to do the area again. I'm going to use 6 as my base now. Are we cool with that? Here's my base. Well, the height has to be perpendicular to it. What's the item that's perpendicular to the base? 8. You see how I extend this line over? And my height is now perpendicular to it. It just happens to be outside of the shape. So my base and my height are once again perpendicular. That's the key. So if we wrote it with these numbers, it would be 6 units times 8 units. 6 times 8 would give me, so my area is 48 units squared. Okay? We get the same answer either way. It just depends on what you want to choose as your base. It does not matter. Okay? This problem, they gave us more information than we needed. Okay? But it does not matter. My point was, you always have to choose the base and the height so that they are perpendicular or form a right angle. All right? Any questions on the parallelogram? Trisha?
I mean, like, there's just one. Like, I see a big parallelogram. Why do we have to? Like, is that triangle just the height, or is that like a part of the thing?
That triangle is just used for the height. We're only looking at the shaded region right now. So, trying to get an example. Let's say the shaded area was a swimming pool. All right. You had some really bad construction, and they tried to make a good swimming pool, but it came out all crooked. Okay. It would not be practical for you to measure across the swimming pool, right? So you can imagine someone measuring off to the side of it. That's all they're doing in this case. They're saying, here's your figure, the shaded area. I want to know this distance, but I, for whatever reason, don't want to go across, so I'm going to go off to the side. So the 8 and this SU, this triangle, is all just to show the measurements. It's not, we don't care about it. We use it to find the parallelogram area, but we don't care about the actual triangle here. I should have made that clear. I should have said find the area in the perimeter of the shaded area. Okay. Yep.
Can we just make a line down to Q instead of R?
Sure. So Patricia said, would it be possible for us to have this line? Would it be perpendicular?
Yeah.
What would be its length? Yeah. So that would be the height too. Could I draw a line from right there?
Yeah.
What would be its height?
8.
Yeah. It doesn't really matter. They just chose point 8 or point R. Okay? All right. Now, to make these, if I give you a triangle and I say find the area of it, it's going to be so easy, right? Because you just plug in some numbers, check it out. The base of a triangle is twice its height. The base of a triangle is twice its height. If the area of the triangle is 36 square inches, notice the units. Notice the units. Then find the height. Well, what shape are we going to use? So what should I do? Draw a triangle. Does it matter what kind of triangle? Because does the formula depend on what kind of triangle? All right, so what do you want, acute, obtuse, or right? I heard right most. Okay. What else am I going to need to write down? The little square for the right. Okay, that's fine with me. So we know that the area of the triangle is 36 square inches, which is inches squared. What's the formula? Half the base times the height. If we're looking at this one, which one's my base? Bottom. This is my height. Alright, so set it all up. Put down as much information as you can. Now the last part is we know that the base of the triangle is twice its height. So does this look like the base is twice as big as the height? No, so maybe I should redraw it a little bit. So maybe I should draw something like that. Does this look now like the base is roughly twice as big as the height?
Yeah.
Okay. And I know that the entire area inside, all this area, is 36 square inches, right? But I don't have any other numbers. I don't have any other numbers. What could I do? Jason?
So what I did was I doubled 36 and made it 54.
Why?
Well, because it says 2 1/2, I did the opposite.
Okay, that's fine, but then you said I still have the problem with the base and the height to deal with, right?
Yeah, but I figure out 2 numbers.
But aren't there multiple options that would work there, though?
Yeah, but there's limits,
In what way?
of therapy. Well, I got 12 and 6.
So you, Jason, perfect, but your method would be inefficient. So it's good for this easy problem, because your method was guess and check, right? You found a bunch of numbers that worked, and you're like, oh, this one's twice as much. That's great. If you get stuck, totally do it. Can I show you the way that will get it right away, though? Because if it's a harder problem, like let's say if it's like 122 square inches, you're going to have a lot more options, and it's going to take a lot more time. All right? What do we do when we don't know a number? X. So let's say that the base of the triangle is twice its height. So the base is what then? 2x. And what's the height? X. Do you agree that the base is 2 times as big as the height? So then we plug them into our formula. What's my area?
36.
So 36 inches squared equals half. What's my base?
2.
What's my height? Now we can solve that. Okay. We get 36 inches squared. What's a half times 2? 1. So what ends up happening to a half and a 2? It cancels. So then what do we get left? X squared. Remember, x plus x equals 2x. X times x equals x squared. Here we have x times x, so it's x squared. Last step, take the square root of both sides. We get x equals, what's the square root of 36? 6. And then the other thing to notice, what happens when you have a square root and a square? So what do you get left with? Just inches. So x equals inches, but what did x stand for? The height. Is that what it asked for?
Yeah.
Yes. So the height then is equal to, what is it? 6. 6 inches. What does the base equal? 12. Okay, so be very careful at the very end. Don't leave it as x equals. Go back and say the height equals or the base equals, so I know exactly what you're talking about. All right? So steps, draw a picture, write your formula. You can start with those. Those are easy. Then plug in what you know. The base of the triangle is twice the height, so we know that this is 2x and that's x. Then it's just algebra. Okay? Plug them into the formula and simplify. Always go back and check your work, too. What's 6 times 12? 6 times 12. 72. Then a half to 72? 36. Okay? Now, for complex shapes, we can split the polygon into simpler shapes, all right? So for complex shapes, I want to find the area of the shaded region only here. So see that little triangle off to the side? That is not part of my shape, to the right side. However, do you see the triangle to the left side? That is part of my shape. All right? This one's already been broken out for you. You see this shape, and if I saw the shape, we don't have a formula for this weird-looking thing, right? It's not a parallelogram, because that's the parallelogram. There's this extra piece added on. We don't have it, but we do have the formulas for those two different shapes. All right? So everybody sees the split here? We have the area of a polygon, And we also have the area of a... So the area then, for the whole thing, has to be equal to the area of the parallelogram plus the area of the triangle. Are you guys okay with the fact that I can add these two together to get the whole? The whole shaded area? Are you okay that if I add the triangle area plus the parallelogram area, I end up getting the entire shape? Yes. Okay. So this is just a matter of a longer problem. Once again, use the formulas. What we're going to do is we're going to find the area of each one separately, and then at the end we're going to combine them and add them together. Does that make sense? Because we don't have a formula for this weird looking thing, but we do have a formula for the pieces within it. Okay? So we need to chop it up into two pieces. The first piece is going to be, whoops. The first piece is going to be my parallelogram. So what's the formula for a parallelogram? Base times height. If I look at my parallelogram, what would my base be for my parallelogram?
11.
So is it 16 or 11?
11 because 16 is all the triangle and the parallelogram.
So Jose's got this one correct. Jose said it has to be 11 because 16 includes this little piece from the triangle, right? The parallelogram, though, ends right here. So this is too big for the parallelogram. If we look up at the top, though, we know that it is. And this piece down here also has to be 11. Okay? So my base will be, the area of the parallelogram is going to be 11 meters. What's the height? 10. Are we getting better with the height now? Times 10 meters. So the area of the parallelogram, 11 times 10, 110. What's my units? Meters, because you get meters times meters gives you meters squared. Are we okay with that one? All right, let me erase this. And we're going to find the area now of the triangle. The area of the triangle, what's the formula? Half the base times the height. What should we use for the base? Please raise your hand. Mauricio? 5. Why 5?
Because it's 11 feet on this parallelogram, and you subtract, basically subtract 11 from 16.
Okay, so Mauricio knows the whole thing is 16. We agree with that?
Yeah.
We know that this piece is 11. Do we agree with that? So what's left over for this little tiny piece? 5, because 5 plus 11 has to equal 16. So this piece here has to be 5 meters. Are we okay with that? Are we okay with that? What is the height? 10. Do you see the height? Do you agree that that would be the same as if it were right here? So this is also 10 meters. Notice that it's also perpendicular to the base. If we drew this line over, see how it forms the perpendicular lines? So the area of the triangle then is half the base, which is 5 meters, times the height, which is 10 meters. Once again, the way I would do this, half times 10, what's half of 10? 5 times 5. So the area of the triangle is 5, or 25. What's the units? Meters squared. Your last step then, add them. So the area is equal to 110 meters squared plus 25 meters squared. So the area as a whole is 135. What are my units? Is it meters squared or is it meters to the fourth?
Meters squared. Meters squared is not multiplying.
It is meters squared because we are no longer multiplying. Just like if I had 2x plus 3x, you would say 5x, right? So when you add, you keep the same units. When you multiply, you add their exponents. So when you add, you keep the same units. Marcel? Also, a hint, if we're ever talking about a length, like a base, a height, etc., the units are always just going to be unit. So it's going to be centimeter, meter, feet. If we're talking about area, it's always going to be unit squared. Okay? Talking about volume, it's always going to be unit cubed. Okay? Can we ever get units to the fourth in real life?
Yes.
No. Because what are we? Are we 1D?
3D.
We're 3D. So that's why we can only get units to the third. Right? There is no fourth dimension.
What about
Well, kind of. Alright?
What will happen if there is?
Well, people say there is. The other thing we can do is we can subtract an area. I want to find the area of the shaded area. I want to find the area of the shaded piece. But we don't have a formula for something that looks like that, right? Well, what do you have formulas for? A square and a... So in this case, what I'm going to do is I'm going to find this area of the square and then subtract off that little tiny triangle. Do you see that? So it's like somebody came and ate a piece out of the square with a triangular mouth. Alright? So my area total is going to be equal to the area of the square plus or minus? Minus the area of what? Triangle. I don't think I need to do the formula for the square. You kind of up here? You with me? So what is the square? It's going to be, which one's the side for the square, the 5 or the 8? 8. So what's the area of the square then? 8 times 8. Which is? 8 times 8, not 8 times 2. So the area is equal to 64, sorry, the area of the square is 64, what's my units? Inches squared. Now the triangle is going to be a little trickier. Area of the triangle. What's my base going to be for the triangle? Raise your hands, please. Anthony? I'm sorry? This one? Which way do you want to go, down or up? Guys. Anthony, what were you saying? 8 and 5 would give me what? What is 3 though? Yvonne?
Would it be the height from the
Yvonne said 3 would be the height. Everybody look, please. Gentleman in the corner. It would be the height from this vertex up. You see how that forms a right angle? If this is 8 inches, how much is this side going to be, the whole side? And if the whole side is 8, and this little piece is 5, that leaves what left over? So this is 3 inches. That is not the base, though. That is the height. It goes from the opposite side to the other corner, or the other side. What is the base? 8. Sorry, Lisa. Base is 8, because it's a square, so the other two sides must be equal. So plug it into your formula. It's half the base, which is what? 8 inches, times the height, which is 3. So you can do this however you want. I like to do this part first. Half times 8 is times 3? 12. You could also do 24 divided by 2. It's still going to be 12. 12 inches squared. Last step, do we add or subtract? So my area total is going to be 64 minus 12, 52 inches squared. Okay? So if you get a complicated shape, try and break it into pieces that you know, and then use your formulas. Confusion about this 3, or are we okay with that? Confusion about the base versus the height? Okay. All right. Tricia?
Is there another way of checking this area without having to just like do the problem?
What do you mean by checking the area?
Like, you know how we had in our other problems we can just plug back in the number and see if it's right.
Uh-huh.
That's what we're checking the area.
You can't really. Yeah, you really can't. Problems like we did, problems like this, you could check, because you solve for the height. You could plug it back in and make sure it makes sense, right? Problems like this, where they give you all the numbers, there is no x here. Does that make sense? So there's no way to like plug it back in to make sure if that works or not.
Let me get it.
Potentially, yes. However, please check your answers in the back of the book while you're doing homework. Okay. The last thing we can do is we can find areas of polygons on the coordinate plane. So first thing we need to do is draw a coordinate plane. It only needs to be 5 by 5. Excuse me? Probably. So you have a 5 by 5. Next up, plot all your points. It's going to be better if your graph looks nice. So spend some time making sure it looks good. So the first point is -2, -2. Next is 5, 1. And the last one is 3, -2. So what sort of shape is that going to be? Triangle. That line is supposed to go through 2. But it didn't. Okay, so there's your triangle. Now we need to find the area. Well, what's the formula? Half the base times height. If you look at the picture, they've been very nice to us today. How do we find the distance if it's in the coordinate plane? We use? Yes? What if it's not so easy, though? What if it's not? What if we can't count? What if it's diagonal? Okay. Distance formula. So we use the big square root, x squared minus x1 squared, y2 minus y1 squared. Right? This one, however, they've made very easy. The base is EG. Does everybody see the base? Where would my height be? Where would my height be? Nicole? G straight up to where? So G right up to here-ish? I disagree. Why? Is that the tallest point of my triangle? Would you measure a building up to like the second to top story? You go all the way to the top, right? So can anybody be a little more specific? Ernest? From F down? Straight down, left down, right down? So it goes this way?
No, like that happened to me.
Right here?
So it's just from F going down. Yeah.
F down? Where do I stop? So I need to draw it from F to G.
No.
Yeah.
Yeah.
Michelle?
Oh, you come. No,
You know, E to G is the base. Simmer down. Go ahead.
You do it from E to F. So you draw the line going up and across.
E to F this way?
No, you draw the.
You could do that. The other way, we need to, Ariel. So we need to, it needs to be a right angle. Notice that I have my right angle there, and I also have a right angle here. Either one of these would have worked. Do you notice that this line here is the same size as this line over here? Then you just count. EG would be 1, 2, 3, 4, 5. So you get 5 times 1, 2, 3. 5 times 3, and then you have to take half of it. Okay? Your homework for tonight? This stuff?
Good morning. Any faculty and staff not teaching right now, please come to staff.
I'll be here after school until about 4. We have faculty meeting today, and then I'll probably be back afterwards, assuming it doesn't last forever, I hope. Alright? So if you need help, if those of you who are taking your tests come early, okay? I cannot stick around and wait for you to show up like 2.5 hours after school today. So just come early after school, check in. What's up? What do you have? That's fine. Do you do both? Or do you need? Do you have a lot? Okay. So come check in with me. I'll talk to your son. Yep. So I gave you very few of the really simple ones. So there are like 2 or 3 really simple ones, but a lot of them are the multi-shaped ones. So you have to add or subtract, okay? Nope.
Seniors should go with their teachers to the lobby as a double floor by American. Seniors to the lobby as a double floor by